Hello and welcome to this NDAR Naval Architecture video, part of the NDAR video library. This video features the Orca3D plugin for Rhino 3D V8, created by our excellent partners at the Orca3D software house. Orca3D offers a complete set of naval architecture tools. In this video we'll review and explore the Orca3D Hull Assistant toolset. The Orca3D Hull Assistant toolset is designed to generate early design hull models in a short time, thereby allowing various naval architecture and design activities to be carried out in parallel from the earliest stages of the design cycle. The end goal is to fully validate the design in the shortest possible time. More videos addressing the overall design ecosystem are available from the NDAR and Orca3D video libraries. This video is divided into 5 sections. Open Rhino. Create a new file using the Large Objects Meters template. Here are the target values of the hull's main particulars and coefficients that we seek. Now we will set some Rhino and Orca parameters. From the Tools pull-down menu, open Options. In the Units panel, set absolute tolerance to 1 mm. The angle tolerance to 1 degree. And display precision we will set also to 1 mm. Model units are already set to meters as we have used the Large Objects Meters template. Click OK. From the Orca3D pull-down menu, open Properties. Change current units to SI ton. Set model orientation forward to -X and up to +Z. In the Hydrostatic tab, leave fluid type as seawater and keep the rest parameters with default values. Click OK. From the Orca3D pull-down menu, open Hull Design, Hull Assistant. There are 5 types of hulls which can be designed with Hull Assistant. For the sailing boat hull, we will choose default Sailboat Assistant. Open Assistant. Change the description to Sailboat Hull. There are 2 tabs in the Sailboat Assistant window, Dimensions and Shapes. We will start with main dimensions of the hull. During the design process, we would like to see the current stage of the shape, and changes were produced by changing the different parameters. Check the Preview Hull checkbox. We would also like to see the sections. If necessary, custom sections can be defined. We can also get a live preview for selected hydrostatic parameters at a time. You can choose parameters from a list of available parameters. We will choose block coefficient, vertical prismatic coefficient, displacement and vertical position of center of buoyancy. Set length on deck to 24 meters. Beam on deck to 8 meters. Deck height at bore wheel set to 2.5 meters. Deck height at transom to 1.85 meters. Transom height is the elevation of the lower transom point above the design waterline. We will set it to 0.32 meters. Canoe body depth set to 0.55 meters. Moving a slider, you'll notice that the shape changes and hydrostatic parameters change as well. We will proceed with the shape setting. Switch to the Shape tab. Bore rake angle will set to 4 degrees and transom rake angle to 0, as desired. The shear height is a fraction of the deck height at bore, and shear height position is a fraction of the length on deck. We'll set them as 0.8 and 0.5 correspondingly. Beam at transom is a fraction of the beam on deck. We set it to 0.9. Deck beam position is a fraction of the length on deck. We'll set it to 0.6. Canoe body draft position is a fraction of the length on deck and will be set to 0.43. The dead rise value controls the slope of the surface as it runs from the bilge toward the center line. A dead rise value of 0 means that the surface will approach the center line horizontally. We'll set it to 0. Flare value controls the shape as it moves up from the bilge towards the shear. Flare value of 0 means that the surface will approach the shear vertically. This parameter we'll set to 0.2. The shape of the hull is also controlled by the bilge tightness. A value of 0 yields a very tight corner. The higher the value, the more slack the bilge will be. Bilge tightness and dead rise flare are interrelated, so a little experimenting with these values with preview turned will help to attain the desired shape. Set it to 0.4. A 4-foot shape of 0 yields a sharp corner, discontinuity, and a value of 1.0 yields a very soft 4-foot. We'll set it to 0.4. As you can see, hydrostatic parameters values are higher than planned. So, we need to slightly change the definitions. We choose to intervene on the dead rise parameter in the Shape tab. We will change it to 0.1. Thus, we have matched concept target values closely enough for this hull to be used as base for ensuring design work, to hydrostatic initial check, compartmentation and damage hydrostatic, CFD, 3D general arrangement, preliminary structure layout, seakeeping, etc. Save settings. Now we can create hull. Open the pull-down menu and select Create Full Model. This concludes the presentation of the Hull Assistant toolset. Thank you for watching this NDR video featuring Orca3D.